taxis. This is quite an easy investigation. This is section A, but what I'm going to do is change the numbers slightly and show you what to do. So creating a new document. Let's paste the investigation here and change the numbers so I can go over a similar but different example. There are a couple of graphing tools you can use online for this investigation. Let's change this number to 6, 7 and €1 and €1.50. So complete the following table for each speedy and timely taxi. So what I'd do is I'd copy this table and paste it. Basically, what this investigation is looking at is whether you should take speedy or timely taxis based on your distance. And you're going to model this using straight lines. So if we go for speedy to begin with, they charge a flat rate of €6, which means when you get in the car, you are already charged €6, and then every additional kilometre is an extra euro. So after 1 kilometre, it would be 7 because you add together the 6 and the 1. The flat rate of getting in plus 1 for an additional kilometre. And because for every kilometre you go up in, the cost for this one goes up in ones, and this is because it's an additional euro per kilometre. This would also be very similar. You take the 7 and then you take the 150, you add them together, 850, and then 150 for each additional kilometre. What you then need to do is you need to go onto Desmos and you need to put this side by side. So let's put the table on one side, and then on the other side we're going to put Desmos as so. And to add a table, what you would do is you would click the plus button. And the way you find the plus button is from this menu here. If you make it too small, it disappears. There we go. Table. And instead of writing the table going horizontally, all you're going to do is write it vertically. So the x-axis is going to represent the distance and the y-axis is going to represent the cost. So we've got the distance versus the cost. You then do it for another table, so you'd press plus and add another table for your second table, and you would compare the lines. For example, we might have the other table showing something like this, and the first table might show something like this. Now these two graphs are very interesting because at one point for an equal distance of 5, both the taxis are the same cost, which is 11, but beyond this distance of 5, this taxi becomes more expensive and this taxi becomes less expensive. This is the whole general gist of this investigation. You're going to be plotting straight lines, seeing where they intersect, and talking about things such as gradient and the y-intercept. Clearly the y-intercept represents something important in terms of the taxi investigation, and the gradient represents how steep the line is and therefore the cost per kilometre, for example, but not always. Let's briefly discuss section A and finishing off with section B. So we've done up to question 4. So this is just reading from the graph, which I've just recently discussed. And the same amount, again, I've talked about intersections and important things like that. Now let's have a quick overview of section B, but not too much. You need to do the same this time, but for another 2 taxi companies, you need to repeat the process for section A by doing exactly steps 1 to 4, but they give you a little less information and you have to create the table for this section. The flat rate Well, we discussed the flat rate is going to be the cost when you get in the car. And what distances do you need to travel so that discount taxis are the cheapest of the 3 taxi companies? So again, with this, you would have a look at the graph and you'd explain, well, at what point does it become cheaper? So if I was comparing these two graphs and I was comparing, let's say, taxi company 1 and taxi company 2, taxi company 2 would become cheaper after 5. So I could write this using an inequality. So let's say this is going to represent the kilometres. So 2 is the cheapest when x, or you could choose your own variable, is bigger than 5. And I meant to write 1 for this actually because it is taxi company 1 which is cheaper rather than 2. 2 actually becomes more expensive when x is greater than 5 in comparison to the other taxi companies. I hope you find that useful. I'm not going to give you too many answers because I don't want to do it for you. Have a look at video 2 once you've completed section A and B. Good luck.